Hello everyone. I'm currently taking a class in microprocessors, and one of the things we just learned about was how to use a keypad as an input device, and we also learned about serial communication with our board. Today I decided I wanted to try a different kind of input device, namely an NES controller, and I wanted to use a different kind of microprocessor to see how serial communication was handled by it. So for today we're going to be using a little Arduino. And you can see I already have everything wired up. The port from the NES controller has 7 pins. 2 of them are used for power, so 5 volts and ground. And then there's 3 outputs and then 2 unused pins. The 3 outputs, one is a latch signal, one is a strobe signal, and the other is a data signal. And they are all going to digital inputs on the microprocessor. And from the microprocessor is hooked up to a standard A to B USB connector, which will be plugged into the computer, and that's going to be used to power the board as well as do the serial communication. So let's go ahead and plug it in. Okay, so I can see the board start to light up. And over here we're going to download the code onto the board. And then I'm going to connect to a program called baud, which is just a terminal program. It's free, it's available online. Okay, and so what this program is going to do is, whenever I press a button on the keypad on the controller, it's going to output a string saying which button I just pressed. So for example, if I press the up key, the string up is displayed on the terminal. And if I press down, down's displayed, left, right, and it's also true for A and B, start, select, and just so you can verify that I'm actually pressing the right buttons. Here's down, here's right. So one thing I want to talk about is something called the baud rate. And the baud rate, if you've never heard the term before, one way you can think of it is kind of the language that the microprocessor and the terminal program are using to communicate. So in other words, if they're different, then it's not going to work and you're not going to be able to communicate effectively. So for example, right now I have the program broadcasting at a baud rate of, I believe it's 38,400. And then over here you have to set the same setting. So for example, if I were to change it to one of these other baud rates, you don't know what you're going to get. It's probably going to be gibberish. So for example, let's say that 38,400 is Spanish. Okay, so my microprocessor is speaking in Spanish, and if I change my baud rate or the language to 9,600, let's say that's Navajo, then let's see what happens when I press the buttons. Well, you get all sorts of weird symbols. Alright, so as you can tell, the computer no longer knows how to effectively communicate with the microprocessor. And if we change it to another one, say 56,000, then we're going to get something else. So that's kind of weird. And of course, if you go back, so they're both on the same baud rate, okay. Another thing I want to show you, so that's the serial communication. I also wanted to show you, I have some more pins coming out of the microcontroller, and those are output pins. And I'm using those to go to the solderless breadboard, and they were hooked up to an LED bank. And the reason why I did this was to show that you could also control other things than just a serial communication, but you could actually control a motor or a light. So for example, each of these LEDs is hooked up to a different button. So for example, if I were to press the A button, you can see that light comes on, and then B is the one next to it, and then start is another one, selects another one, up, or right, up, left, down. They're all different lights. So the idea is that you could actually send this this signal to like a motor controller and actually, you know, drive a robot using the NES controller to control the motors. All right, so if you have any questions, feel free to leave comments and check out my other cool videos on robots that I'm working on, and have a great day. Bye.